Welcome to Executives at the Edge, a podcast brought to you by MEF. I'm your host, Pascal Menezes. Join me as we explore thought-provoking perspectives from the leaders and changemakers who are propelling enterprise digital transformation forward. Well, it's with great pleasure to introduce Guru Belur. He's the chief architect from VMware by Broadcom. And today we're going to cover really a fascinating topic with all this AI buzz. How does SD-WAN and AI work together? So Guru, with that, thank you so much for attending and participating in Executives at the Edge. And for our listeners, can you just give us a background of yourself and really what VMware by Broadcom does?
First off, thank you so much, Pascal. Love the conversations that you have in the series and really honored to be part of it. So my name is Guru Belur. I'm the chief architect for SASE and Edge within the software-defined Edge division at Broadcom. Our charter within this division is to build the digital infrastructure for connecting, securing, and running workloads outside the data center, what you would traditionally call the edge of the network, right? So our definition of the edge is rather expansive. On the one hand, it includes things like branch offices, campuses, factory floors. On the other hand, you could have things like an OT device on a tilling machine on a farm somewhere, right? And everything in between. So it's a wide breadth of infrastructure that we need to kind of run workloads on and connect the workloads together to make sure that you have highly distributed applications running on this infrastructure.
Well, Guru, that's really, really interesting. So what is really going on? We know we have all of this AI that buzz that's started happening. Gen AI has really made AI top of mind everywhere, but Edge has always been talked about for a long time. So what is the state of the market? Why Edge workloads in general, and how does it interact with AI workloads in particular, and why all relevant at this point in time?
Yeah, so if you look at the kind of the application landscape and the infrastructure that it runs on, that's how it's evolving. We're starting to see, as I said, a lot more workloads running outside the traditional data center. Now, most of the times, this is not in lieu of workloads in the data center, but in addition to it, right? So Gartner put out a study earlier this year where they said that by 2027, they expect about 50% of all enterprise managed data will be produced outside of the data center and public cloud infrastructure, essentially at the edge. Now, when you have that volume of data, you want to use that data to essentially drive better outcomes to users, right? So that's really where you have AI applications coming in, where there's vast amount of data that's getting produced. You want to consume it, and you have this AI kind of layer on top of it to make sense of all of that data. Now, our expectation is that about 50% of the edge workloads in the next 2 to 3 years will have some flavor of AI to it, right? And the question then is, why do you need to run these applications at the edge? Why not just run them at the data centers? And when you look at the requirements and sort of the expectations that these applications have, they fall into kind of 3 large categories. The first one is a lot of these applications are very latency sensitive, right? So they have very tight requirements in terms of what is acceptable latency for these applications. Think of things like a robotic arm on a factory floor or an autonomous car that's making a steering decision and things like that. You have to be able to kind of consume that data close to where it's produced, and there's a near or a real-time or a near real-time aspect to how data is consumed and how inferencing is done and so on, right? So sort of one class of applications that we're seeing. The second class of applications that we're seeing is you have environments where your network connectivity may either not be present or the network connectivity might be very flaky, right? So think of, say, a police car in the middle of nowhere and driving at 100 miles an hour, and that needs to fire up a nameplate recognition application to see what's going on and things like that, right? So not really practical for you to go back to a central data center to process that. So a lot of workloads that are running where connectivity might be a little iffy. The third requirement, and this is kind of goes back to the Gen AI angle that you're talking about, a lot of applications where there is data privacy and security concerns, where you have lots of data that's either enterprise level data or data that's produced on a retail store somewhere and things like that. You either don't want that data to leave the edge, or in some cases it may just not be feasible for you to leave the edge given the volume of data and things like that. But you still want to use that data to drive better application outcomes, right? So if you look at these three things, latency, network connectivity, data privacy, you kind of get into this architecture where you have applications running more and more at the edge. But these are not isolated applications, right? So all of these applications are part of a larger fabric of applications. It's highly distributed. You have a connectivity angle, but more of the compute capabilities are now running at the edge.
So I think this is a really important aspect, that basically we have models and AI models. They will live in different aspects based on their requirements of inference, of latency sensitivity inference. Mm-hmm. But then you're also saying there's connectivity angle where there's not always connectivity, right? And then the whole idea of privacy is a very big concern, because I know a lot of enterprises are very concerned. First of all, their data is all encrypted, so it's hard to get to it. Yeah. So when you see, how does it all come together? How do you see this coming together then?
Yeah. So we kind of liken the infrastructure for you to run workloads to a sandwich cookie, right? And kind of bear with me as I work through this analogy. The top layer of the cookie is the compute infrastructure, right? So, and Pascal, as you know, we at VMware have a rich heritage of being the sort of the virtualization of platform of choice for the data center. We're taking a lot of that, and by the way, a lot of what I'm talking about applies more generally as well. We're taking that and we're adopting it to the edge, right? And what I mean by that is, you want to have paradigms around things like, say, a pull-based orchestration system. It's not fair or it's not possible for us to kind of expect a central management system to go work across this highly diverse, large number of sites and those kinds of things. You cannot expect them to push configuration down, right? So you need to have some level of autonomy in terms of all of these sites and how they get configuration and manage the configuration. Kind of leads us into things like a desired state managed paradigm, making sure that you have infrastructure as code and those kinds of things, right? So a compute platform where you can actually run workloads, but something that's adopted to the edge. So that's kind of the baseline for how we run compute workloads. On top of that, you have specific requirements for AI applications, things like GPU pass-through, making sure that you have sort of data services for things like if you have a message bus that needs to connect applications together and so on. We think of it as kind of AI logical infrastructure. Another example is things like you have sort of a model server that's running on the edge, which is able to kind of get models down and make them available to applications. You want to make sure that there is telemetry built in so that you know how what is the efficacy of your models and those kinds of things, right? So that's sort of the top layer of the cookie, the compute layer where the workloads are actually running. The bottom layer of the cookie is the network infrastructure on which these applications are actually running, right? So in addition to traditional kind of wired internet, MPLS connections and things like that, we're starting to see tremendous growth in areas such as fixed wireless access. Could argue it is something that is transitory as so we migrate from copper to fiber and things like that, but you are seeing more and more kind of enterprise use cases around things like fixed wireless access. Satellite connectivity is becoming a key part of how enterprises are consuming the internet. So you have a lot more options in terms of connectivity, but there's also a lot more variability in terms of what these networks offer, right? So you have the compute infrastructure on the top, you have the network infrastructure in between, and more importantly, kind of the creamy filling in the middle of this cookie, which really kind of ties everything together, is WAN connectivity with SD-WAN, right? And what it really does is it kind of decouples your applications from the network infrastructure that it's running on, and really kind of lets application developers do what they do best, which is build an application to a certain SLA and have the SD-WAN infrastructure realize that intent on a wide variety of underlays, right? So having a key networking fabric that kind of brings together all of these elements is key, right? So in the context of VeloCloud, we term this VeloCloud RAIN, or VeloCloud Robust AI Network, where we're using AI within our SD-WAN offering to help run AI applications on the edge, right? So when you do that, we believe that kind of bringing all of these solutions together will give you a really kind of robust mechanism to run edge AI workloads.
So can you go deeper about what you mean by SD-WAN? So is SD-WAN coming from the user sites and using SD-WAN to get to these edges?
Yeah.
And then what about between the edges? Is SD-WAN also being used? Can you help us with that?
Yeah. So if you look at the kind of the broad classification of the kinds of applications, the kind of AI workloads that are running on the edge, there is kind of the traditional AI applications, right? These are things like an image recognition application, things of that nature, where the compute requirements that I outlined are important, but for the most part, the application is running on the edge. Now, increasingly, you have a second category of applications, things like generative AI applications that are highly distributed, right? And this is an area that's evolving so quickly that what was kind of state of the art 6 months ago is kind of legacy technology now, I guess. But what we believe is, and what we're seeing more and more of is, you're sort of moving towards a sort of a highly federated learning model for Gen AI applications, where you have kind of large language models, trillions of parameters, you have inferencing engines that are running over there. These are all running centrally within large data center, right? But increasingly, they are getting complemented by SLMs or small language models that are running on the edge, right? And as I said, our definition of the edge is very broad. Anything outside the data center can effectively be an edge. And the SLMs are running highly kind of specialized models, a lot smaller, a few billion parameters, for instance. They're running on edge hardware with things like the NVIDIA Jetson GPUs and things like that. So you have a much smaller form factor that is actually running on the edge. But the way these things typically work is the SLMs may not really have all of the context or the capabilities to be able to answer a user prompt. So the way this typically works is a prompt comes in, the SLM takes a look at it, and then it hands off the tools and capabilities that it has to an LLM to essentially go in and say, look, how do I best answer this query? The LLM either comes back with a response, it comes back with things like, these are the functions that you need to invoke, these are the arguments that you need to call out, or in other cases, it will basically come back and say, these are the other entities, right? So think of this as a highly distributed mesh where you have a central data center and you have all of these edges that are part of that mesh. And there is a lot of communication going back and forth in terms of either edges talking to a data center, edges talking to each other, and so on, to essentially kind of make sure that you get the best result for your applications, right? That's sort of one element of it. The other element where SD-WAN actually becomes very important is the nature of the interactions themselves are actually changing quite a bit, right? So if you look at sort of traditional web applications and the access patterns, there is a heavy bias towards downloads, right? So you have a request that goes in, fairly small. Most of the response is that's the larger one. And that's how networks are set up, where your upping capacity is a lot lower than your download capacity and those kinds of things. That is changing significantly in a Gen AI application. What ends up happening there is you have these pre-trained models, but for you to kind of bring in additional context, either it's custom data, it's data, sort of real-time data and things like that, you augment that data, you create those tokens, you send it over, right? So you have requested summarization where a call like what we're having right now gets uploaded to a site and you want to kind of get the summary of the sites and those kinds of things. So data tends to be very bursty. The upload capacity that you would expect tends to be a lot higher. So the nature of both connectivity in terms of who needs to talk to whom and just the kind of the profile of the applications and how they're talking to each other changes significantly, right? So and when you do all of that, it all starts with making sure that you have a secure overlay that can connect all of these actors together to make sure that you have the best network capabilities for running these applications.
So I think that's really brilliantly said. And if I can just re-summarize, and what you're saying is where the large language model sits, and they normally have trillions of tokens, as you say, and they have tens of thousands of compute nodes. They sit in very large data centers, and they train within each other to keep them self-trained, and they take a ton of bandwidth. That's not what we're talking about SD-WAN. That's probably more wavelengths, right?
Correct.
Wavelengths at 100, 400 gig, 800 gig between these massive large language models or these Gen AI kind of large models. They basically have a different requirement of networking, which is more wavelength and so on. But then as these large language models start communicating with these edge models that are smaller and more finely tuned, they have to work with the larger models and smaller models have to work together. That's a good opportunity where SD-WAN over transport makes sure that the requirements for latencies and so on, performance, are met. Is that correct?
Exactly. So what's going on with kind of network connectivity within the data center, that's a topic for a different day. What we are focused on today is really more on the wide area network side, which is really kind of ties back to how users are communicating with those applications, right? And again, as I said, the network connectivity piece is one element, and that's a key piece. But that's not necessarily as sufficient for a lot of what we need to do, right? So we take a deeper look at how we approach AI applications in general and how SD-WAN needs to kind of adopt to that. And for us, there are kind of three pillars that we need to build on top of the SD-WAN framework that we have. The first one is really around identifying user and application context. The more I know about an application, the better choices we can make for the application, right? So obviously, I need to know what the application is. That's not necessarily sufficient. I know, hey, this is a ChatGPT application, or this is something else. What is the expected behavior of this application? What are network profiles that we expect this application to do, right? So sort of one part of what we need to do is kind of learn the behavior. And this is where things like offline training, looking at application patterns over time and kind of making sense of that and coming up with application signatures is critical for us to kind of make the decisions that we need to do. So sort of one element of what SD-WAN needs to do to kind of better work in this.
But that's really the essence of SD-WAN is application signatures, recognizing those encrypted
Correct.
flows, classifying to the right application type. So that's continue.
And this is a little deeper than that. Now, traditionally, SD-WAN would go and take a look at an application, say, oh, I know this is application X. What we're looking at doing is taking a look at the application and going in one level deeper to take a look at, hey, look, this application, what is the behavior of this application? What are the different kind of subflows within this application? If there is a model download that's happening, I probably want to prioritize that different from a real-time query that's happening. And if I have the ability to kind of identify signatures within the application and know what's really going on, we can actually drive much better outcomes into the application. Now, there's a challenge in terms of how do you do it? All the traffic is encrypted and things like that. That's when we'll have to rely on AI and ML within our product to make sure that you have better outcomes for AI applications in general, right? So it's sort of one element of that. The second element of it is kind of the bread and butter of SD-WAN, right? So how do you optimize network connectivity for wide area networks under various underlay technologies? Now, VeloCloud has things like what we call dynamic multipath optimization. Every SD-WAN vendor out there has different set of optimizations that we can do. And the goal for all of these things is how do you kind of make sure that you have the best user perceived quality of experience, right? So we are taking a lot of the baseline capabilities that we have within our SD-WAN offering and changing that to better suit AI applications. Some of these things I was talking about in terms of change in network patterns, heavier bias towards upload traffic versus download traffic and things like that. How do you kind of make sure that we adopt to that? That's sort of one area. Another area that is actually very interesting for us is the emergence of new underlay technologies, right? So whether it's 5G, whether it's satellite links, these all have very different network characteristics. And a lot of that, you could argue, applies to not just AI applications, but other applications as well. But it's kind of more important in the context of AI application, given the requirements these applications have. And that is to kind of make sure that if I have a 5G link, for instance, that has the capability to create a network slice, how do I most effectively consume that slice? How do I go map an application outcome? There's a query that comes in from this application. I know it has certain SLA requirements. How do I take that and map it to a network slice, which actually gives me those capabilities? I may not have a network slice available. I would potentially want to go create a prioritized channel within my SD-WAN overlay, which again, knowing what the application is, knowing what the expectation of the application is, we can go dynamically map the application onto this prioritized channel so that you can actually get the kind of network SLAs that you do. Right? So when you do that, the application developer does not really have to worry about where it's deployed, how the network characteristics are changing and things like that. The application developer essentially is building to an SLA. And the operator of the network can rely on technologies like SD-WAN to kind of make sure that you have those SLAs realized, right? So that's the two key parts to it. Now, very difficult to do it at scale, very difficult to do it if you have to go manually run a lot of these operations. So that's when, call it intent-based networking, call it AIOps, that element of being able to kind of map context onto the underlay dynamically based on what the application is doing, what how is the network behaving, how is the network evolving over time and things like that. That would be a key part of kind of building this next-gen AI sort of SD-WAN infrastructure for AI applications.
So I think what you're now saying is there's a very different use case for SD-WAN than when it originally came out, 10 plus years ago, which is all about around AI. And what you're saying now is even better is that because there's such a dependency on the network to have the performance guarantees, that SD-WAN becomes the awareness layer that can classify applications correctly, policies, understand that. And then it looks at the network, and the next layer could be slicing, which on wireless has slicing coming out and continues to come out. But we also have end-to-end slicing that's going to merge, which includes wired side, and that would map to slices. So let's say we only had one link on a wireless link, but it has slicing capability. You could map your application SD-WAN policies to the slices, correct? That
Absolutely.
would give you the guarantees you wanted from the SD-WAN policy level,
Yeah.
right? And then you would map that to the slice, and then that would then give you the guarantees of performance guarantees of delays and latencies and losses.
Absolutely.
And then that would map out correctly into the nearest edge that has a model that maps to the requirements. And so now you have this idea of SD-WAN and slicing and networks all coming together around the AI requirements, which in the past was always about mission critical applications, but not around AI. And this is where you're talking about.
Exactly. And in fact, over the last few years, there's been general chatter about how the SD-WAN is a lot less relevant in terms of sort of as a technology, given how the industry is moving. I would argue that kind of the chatter about the demise of SD-WAN is vastly exaggerated. At this point, given how these AI applications are evolving, having an SD-WAN-like layer, which really kind of knows what your applications are, what your application outcomes are, and things like that, and really mapping it down to different overlays, right? You mentioned the example of wireless. That's the key thing. But you don't really have to worry about whether it's wireless, wired, whatever else. The application is essentially built to work against a particular SLA, and a layer like SD-WAN will realize that across a wide variety of deployments, whether it's satellite, whether it's wired, wireless, all of these things, right? So a very powerful kind of paradigm to kind of tie your applications down to the network.
You know, Guru, what a fascinating topic. And you're so right. Everyone's talking about, oh, SD-WAN's kind of, it's legacy, it's mainstream, it doesn't really have any legs. SASE's pulling in SD-WAN now, and SD-WAN's kind of old school. But what you just described is a rebirth of SD-WAN in an AI generation. So it's very powerful. So Guru, thank you for being part of this episode, and I'm sure we'll catch up with you very soon.
Wonderful. Thanks for the opportunity, Pascal. Great talking to you.
Thanks for joining us for Executives at the Edge. Don't miss an episode. Subscribe today. Share online a review. Find all our episodes on your favorite podcast platform and at MEF.net.